Okay.
Okay, ready? Okay, our topic was algebra, and to just go. Okay, and to briefly go through the history, the earliest algebraic ideas came from Mesopotamia about 4,000 years ago, and it's also known as the Babylonian mathematics. And in Mesopotamian mathematics, there are two roots which include accountancy problems and cut and paste. And the accountancy problems came from their bureaucratic system of government, and the cut and paste was used to divide land. And the Babylonians didn't only use equations to solve their geometric problems, they also developed algorithms and procedures to solve the equations.
So the topic of algebra soon arrives to India, and in 825 the first true algebra book was written by Muhammad ibn Musa al-Khwarizmi in Baghdad. The main idea of the text mainly came from al-Jabr, which is spelled like this. And that later became known as what we know, algebra. So al-Khwarizmi is the father of algebra, and he classifies the equations in this book into 6 different types. 3 out of these types are categorized as mixed quadratic equations. For each equation that he provides, he also supports it with an algorithm for its solution. For example, if he has x squared plus c equals bx, he would tell his readers to take half the number of things, square it, subtract the constant, find the square root, and then add it to or subtract it from half the roots already found. So he uses words to explain the algorithm instead of symbols that we use. So back then they used words instead of symbols.
Okay, so al-Khwarizmi also used the idea of cut and paste, but there are some differences. He moved away from just looking at the length and width to divide land, and he provided people with universal algorithms that they could use in their own situations. And due to his al-Khwarizmi's mathematical findings, algebra moved from the geometric stage that occurred during the Babylonian era to the static equation solving stage.
Okay, a few centuries later, Islamic mathematics came up with more ideas and concepts in algebra. So they developed all the procedures of polynomial algebra, including the rules of exponents, both positive and negative, and the procedures for dividing as well as multiplying polynomials. Islamic mathematicians were only able to solve problems up to a degree of 2. For example, they could only solve problems up to x squared. So by doing this, they developed 2 alternative methods in order to do this. So they turned to geometry instead. So Amar Khayyam found a way to solve cubic equations, which was a degree higher. He did this by finding out the intersection of particular conic sections, which is the first alternative, and the second alternative was a much more useful method than the first, and it later became known as the Horner method. The Horner method was developed by William George Horner, and I didn't write down what it is.
Pretty much what he did was, it was like a way for you to manually figure out like the roots of a polynomial equation. And then, so in the 12th and 13th century, Islamic algebra was transferred to Europe. In many European texts, the problems were very abstract and it was very difficult to come up with real-world problems. So in the 16th century, the English mathematician Robert Ricord was the first to do this. He related the problems to people's daily lives, which helped them get a better understanding of the topics. Also in the 16th century, there was a major mathematical breakthrough in Italy. Several Italians figured out how to solve cubic and 4th degree equations. And this led to a changing point in algebra in the 17th century, where mathematicians began to look at other topics instead of just finding the solution for the equations. The increasing interest in astronomy and physics brought algebra to a whole new level. They began to wonder about scientific views such as eclipses and our planets. So all of these discoveries pretty much influence how we look at algebra today.
Okay, so now we're the Lebanon algebra, which we discussed the other day. It is in Oregon, and basically the teacher puts a problem on the board and has the student solve it how they would like whatever method they would want to use. then they would explain it to like they would explain what they did in the problem to the rest of the class. So we had just a short video of one of the teachers, and she basically is just explaining what she does in her classroom, and then there is a problem that they put on the board, and the children explain, like a few of them explain the different things that they did. So this is the video.
I hope it's the video.
What can I say? I love the holidays. The traditions, the decorations,
X out of this one.
and of course, the spirit of giving. Your moment, your dove.
The way I teach math today is so much different than what I used to do, that I see so much more excitement and the learning that takes place with the kids. I've been teaching 20 years now, and I have been really excited about the new philosophy of being able to let kids come up with their own number sentences. Instead of just giving kids a worksheet to do, we develop our own number sentences. Kids develop them together, they develop them individually, and they have a lot of excitement about what they are doing these days. Good, Thomas. I like your choices that you made today. Good job.
My biggest surprise has been how much I underestimated the intelligence of children. In the past, I just used the curriculum and the worksheets, and I found that they were really limited by the curriculum we were giving them, by the materials. And I found that when you just flip the ceiling off for kids and you let them explore any concept, they can really take off and learn.
Plus negative 20, because 5 times 10 equals.
Okay, but if you go plus negative 20, do you think you're going to be in the positives or the negatives?
Oh, take away.
Take away, just take away 20?
Yeah.
Okay.
Plus negative 14.
They learn from hands-on. We do very few worksheets. They create a lot of their own challenges and math problems, and they give themselves much harder problems than I could have ever thought they could do.
Okay, well, I did X plus
X plus I.
They love playing with numbers. They love putting numbers together and taking numbers apart.
Okay, so you get the idea of how successful the Lebanon project is in Oregon. So part of algebraic thinking and algebraic math is patterns, and this is an activity that you could do if you were introducing patterns. So we're just going to take this out. You can work with the pairs.
Working distance, yeah.
And when you get your pattern blocks, I just want you to use them to create a pattern.
Anything that you would like.